All right, folks. When we were doing these geometric mean problems, I handed out some coloring pencils and I asked you to trace along the triangle that the unknown side that you're looking for, is involved with. And you see that it's involved in this triangle right here. It's the hypotenuse, right? And then you do that again because X is an entire side of the biggest triangle, the whole triangle that you see there, right? But in the monster triangle, you see here's the right angle, right? So this is a leg, this is a leg. And we were calling this one the long leg. So when you have similar triangles, and we have similar triangles, right? Because you got a right angle, right? So a pair of matching angles. And then you got this angle down here that's in common in both triangles, right? So what we're going to do is we're going to set up a proportion, which is really what almost every single problem on this page is about. We may not realize it, but when we're doing like the cosine of 20 degrees, we're asking the computer to give us the ratio of the adjacent leg to the hypotenuse for a triangle that's similar to this one right here. So what we're doing is this is the ratio of the adjacent to the hypotenuse on the computer, the triangle that's stored in the computer, but our triangle has an adjacent leg that's X and a hypotenuse that's 12. So even though this side doesn't look like a ratio, when we type it into Desmos, it's kicking out a decimal, it's the fraction that's been converted into a decimal. It is a ratio. All right. So we're setting one ratio equal to another ratio. And when you do that, you got to match up corresponding parts, right? So in this situation over here, we were trying to match up like let's say a hypotenuse with a hypotenuse. So in the red triangle, the hypotenuse is X, right? So I'm going to put an X right down here. And then we were trying to match up a long leg. So in the blue triangle, the X is the long leg. And what's the long leg in the red triangle? The long leg is over here. It's 10. See the red triangles right there, right? Here's the short leg. Here's the longer leg. So let's see here. I'm putting the long legs over here. And then I need the hypotenuse in the blue triangle. Oh, where's the hypotenuse in the blue triangle? Okay, here's the right angle. The hypotenuse is 15. Okay, so now we cross multiply, right? We end up with X squared equals 150. And to get like an X all by itself, when it's squared, the inverse of squared is the square root. So I'm going to take the square root of X squared, and I'm going to take the square root of 150. And that came out to be like 12 something or other, approximately. I don't know if I can see from here on the board. Somebody put it up there. I cannot see it. So let me go over to Desmos and we'll put it into our calculator, right? SQRT of 150, and it comes out to be 12.2, right? I wanted everything rounded to the nearest tenths place. So 12.2 is going to be our answer. Oh, geez, why did I put a 1 there? 12.2 for X. Okay, this I think is the toughest problem to fully understand, with the similar triangles kind of overlapping each other, right? Makes it a little bit more difficult. Now, on the test, it could be looking for this side right here, or it could be looking for this side right over here. And those sides, the Y and the Z, are also sides in two triangles at the same time. So Y is like in that littler triangle, and then this triangle over here, the red one, and Z is in the blue triangle, and then it's in this little dinky triangle, right? So let's try another proportion real quick. And you put Z in these two spots because it's shared between two triangles at the same time. Z is the hypotenuse in the little triangle. The hypotenuse in the big blue triangle is 15, right? Z is the short leg in the big blue triangle. The short leg in that triangle is 5. For the Y, Y is shared between two triangles at the same time. So Y is going to go in those two spots. Y is in the red triangle, and then it's in this little dinky triangle. In the red triangle, Y is the shorter leg. In the blue triangle, or well, not the blue, but in the little dinky triangle, it's 5, right? Y in the dinky triangle is the long leg. In the, forgot what I was doing here, the red triangle, 10 is the long leg. So these are how the ratio is set up. All right, number 2 might be the most important problem of them all. The Pythagorean theorem can be used anytime you have a right triangle and you've got two sides, like we got the leg and the hypotenuse. So a lot of things are based on the Pythagorean theorem. And this is how it sets up. A squared plus B squared equals C squared, right? Leg squared plus leg squared equals hypotenuse squared. And you end up with x squared plus 16 equals 49. You subtract 49 from both sides and you get 33. And then you take the square root of both sides. Okay, here we go again with that square root business. And x comes out to be about, let's jump over here and change the 150 to a 33. 5.7, it looks like. So 5.7, let me just double check, make sure I rounded correctly. I did 5.7, right? Because I'm looking right here, that's a 4 below halfway, right? So I'm going to round down at the tens place. Let's do one more and then we'll publish this video and we'll make another video for a few more. Hey, Pythagorean triples are ones that we have whole numbers for that would work out in the Pythagorean theorem. So on this one right here, there's a poster over there on the wall, and this side is 5 because on the poster it has the numbers 5, and then there's a comma, and then a 12, and then a 13. So this is a leg, this is a leg, this is a hypotenuse. I want you to be aware that those Pythagorean triples are over there, and don't do any work on these kind of problems, okay? So on problem number 3 on the test, I'll just be flat out honest with you. It's another Pythagorean triple, and you just need to look over there at the right poster, okay? Hey, thanks for watching my video. I appreciate it.